Hello everyone, my name is Nikhil sir of support classes of University Holy Road, Shulapur. We have started 8th chapter in science of class 9th NCERT, that is motion. In our previous videos we have completed some part of the chapter. Now only few parts has remained. Please student, if you have not seen those videos, please go through previous videos. I have given those links of videos in my description box. You can check my description box and please see those videos. Now we will move towards next point, and that is the last point in this chapter, that is 8.6, uniform circular motion. When the velocity of an object changes, we say that the object is accelerating. In first video I have told you about the acceleration and velocity. Here, when the velocity of an object changes, we say that the object is accelerating. Means when velocity of object change, that time acceleration is happening. The change in the velocity could be due to change in its magnitude or the direction of the motion or both. And when the changes in velocity would be happen due to changes in magnitude and direction of the motion. Can you think of an example when an object does not change its magnitude of velocity but only its direction of motion? Now some examples are there below side. First you see those examples. First one, rectangular track, then B, hexagonal track, C, octagonal shaped track, and D, that is fourth one, is a circular track. This is a figure number 8.9, the motion of an athlete along closed track of different shapes. Now let us consider an example of the motion of a body along a closed path, that is rectangular track. Shows the path of an athlete along a rectangular track A, B, C, D. See here. A, B, C, D, and this is a rectangular track for an athlete. Let us assume that the athlete runs at a uniform speed on the rectangular parts, that is AB, BC, CD and DA of the track. See here, the athlete runs first uniform motion in this way. First A to B means AB, then BC, then CD and then DA. In this way he will run in a uniform motion. Next, in order to keep himself on track, he quickly changes his speed at the corner. See here. When he come here, that time he want to change its direction. That time at this place the athlete will change his speed. Now next, how many times will the athlete have to change his direction of motion? Now see how many he will change his direction. Here 1, then here 2, then again he will run straight. Here he will change its direction. Third, in this way he will change 3 times. While he completes one round, it is clear that he moves in a rectangular in once. He has to change his direction of 4 times. Then this is a fourth time. First here, second here, third here, and here one. Next. Now suppose instead of a rectangular track, the athlete is running along hexagonal shape path A, B, C, D, E, F here. A, B, C, D, E, F. As shown in the figure 8.9b. In this situation, the athlete will have to change his direction 6 times. See here. First B, C, D, E, F, then at A means 1, 2, 3, 4, 5, 6 means 6 times he will change his direction. What if the track was not a hexagon but a rectangle, but a regular octagon? Now see here, means here. Suppose this track may be this now, octagonal shaped track. With 8 equal sides as shown, A, B, C, D, E, F, G, H in figure 8.9c. It is observed that as the number of sides of the track increases, the athlete has to take turns more and more often. Means if the shape changes, that time he will take more turn. Here he has taken 4 times turn, here 6 times. Now 8 sides are there, 1, 2, 3, 4, 5, 6, 7, 8 means 8 times he will take turn. It is observed that as the number of sides of the track increases, the athlete has to take more and more often. What would happen to the shape of track as we go on increasing the number of sides indefinitely? If you do this, you will notice that the shape of the tracks approaches the shape of a circle, and the length of each the sides will decrease to a point. Means after that we can see that if we increase side, that times turn also increase, and the uniform motion is again changes that time. If the athlete moves with a velocity of a constant magnitude along the circular path, the only change in his velocity is due to the changes in the direction of motion. Means magnitude is same but velocity will change. The motion of the athletes moving along a circular path is therefore an example of an accelerated motion. See here, this is circular path, this is the accelerated motion. We know that the circumference of a circle of radius r. Now here this is circle, and for circle we know that the radius in this way. Suppose now I have drawn this circle. The circle, this is the center of the circle, and this is the radius, this is the r of that circle, is given by 2 pi r. If the athlete takes t second to go once round the circular path of a radius r, the speed v is given by v is equal to 2 pi r upon t. When an object moves in a circular path with a uniform speed, its motion is called uniform circular motion. See the definition. When an object moves in a circular path with a uniform speed, its motion is called uniform circular motion. Now we will move towards on next page. On this page, one activity is there, that is activity 8.11. Take a piece of thread and tie a small piece of stone at one of its end. We have to take a thread and we have to take also a piece of stone, and that piece of stone is tied at one end of the thread. Move the stone to describe a circular path with a constant speed by holding the thread at the other end as shown in figure. I think this situation you have to observe in the farm when the farmer is flying away the flock of birds in the farm. Now let the stone go by releasing the thread, and you have to release that stone at a particular point. Now one question is there, can you tell the direction in which the stone moves after it is released? I will tell you the answer, just we are reading the next point. By repeating the activity for a few times and releasing the stone at a different position of the circular path, check whether the direction in which the stone moves remain the same or not. Now please student, take this note that the answer, when a stone is tied at one of the ends of the thread and rotated, it moves towards tangent direction. The stone end rotates continuously and describe a circular path to move the object at any angle. When releasing the thread, the stone moves towards tangent direction. It places by releasing force and thus gets into a full motion. This is the answer. Please student, I will show you the small example of that also. I think you have seen the racing car. In the racing car scene where the bike riders ride their bike. See here, I will show some of that sport video clip.
जेव्हा आईला म्हणायचं असतं एकूण आणखी मार्ग रोज सकाळी म्हणते वरून एक चमचा आणखी, जेव्हा तिला म्हणायचं असतं
Please wait student, I will show you.
रोज सकाळी ती म्हणते एक चमचा, आईच्या एक चमचा आणखीचा आहे का, एक उडी आणखी, एक शाबासकी आणखी, एक बोटी रॉक्स आणि दुधामध्ये.
Please wait student, some network problem is there. Okay, we will move towards the next part. If you carefully note on being released,
oh shit, he's hanging on to
see here, now it's available.
Loses it, don't run
See
wide
ya.
on the rumble strip on the outside. That looks back
See ya.
on Bella Jack, I think up the inside for third place. Yeah, Bella's got it, so Emma's Melbourne is now getting
In this way, I think see the in a circular path. See how can the bike rider changes its direction with sometimes they keep same speed, in sometimes they will decrease speed, then again it increases. Otherwise, they will keep the same speed or increase the speed. I think you have seen that. Now we will move towards the next. If you carefully note, on being released, the stone moves along a straight line, that is tangential to the circular path. This because once the stone is released, it continues to move along the direction it has been moving at the instant. This shows that the direction of motion changes at every point when the stone was moving along the circular path. Just now you also see at some stages, at some point the direction also changes. When an athletic throws a hammer or a discus in a sport meet, he or she holds the hammer or the discus in his or her hand and gives it a circular motion by rotating his or her own body. I will show you that also clip in mobile if I have. Please wait for some time. You are waiting. Please student wait for just only few minutes. See here, I will show you. See here, this one athlete now who is throwing the discus. See here. I think you have seen.
Very fast.
Now, once released in the desired direction, the hammer or the discus moves in the direction in which it was moving at the time it was released. Means when it desired direction, means once he release in the desired direction, the discus will move in the direction in which it was moving at the time it was released. Just like the piece of a stone in the activity described above. There are many more familiar examples above. There are many more familiar examples of object moving under uniform circular motion, such as the motion of the moon and the earth, a satellite in a circular orbit around the earth, a cyclist, or a circular track at a constant speed, and so on. We have completed this chapter. I think you have understood it better. If any queries there, please student ask your queries. We will solve your queries. Please subscribe my channel and shows me the thumb. If possible, I will show you the motion of earth and the moon. Please wait only just few minutes. Please wait student. Please wait. See here, in this clip, you easily observe that. See here, the moon's orbit is tilted.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow.
See here, they have shown the
But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't
I
we
think
look
you
at
have
twice a month?
understood it here.
The reason.
Only the circular path of the moon around the earth. Now today we will stop here. Please subscribe my channel and give your comments. Thank you.